Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. So we are from group 10. We are going to present about our PPL, and our group consists of 4 members, which is me, Muhammad Ahmad Danish bin Marzuki. Second is Sufi Haziq Shazani bin Hafizi. Next is Hafiz Hafizi, and the last one is Danish Aizam.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hafiz Hafizi bin Hamad. For the failure tables, we can divide into 4 parts. The first is facts, second ideas, third learning issues, and the last one is action plan or resource need. For the facts, we got the number 1 is initial temperature of the hot road glass is 1120 Fahrenheit, and the second is temperature of the room is 76 Fahrenheit, and number 3 is desired temperature for the transfer to the next station is much under 870 Fahrenheit. For the ideas is the rate at which the glass cools down can be calculated using the heat transfer equation. And number 2 is the time taken for the glass to cool down to below 817 Fahrenheit can be determined by finding the time required for the temperature to decrease from 910 Fahrenheit to below 817 Fahrenheit. For the learning issues, the number 1 is how to calculate the rate of heat transfer and its effect on cooling time. And number 2 is how to calculate the time required for the temperature to decrease from 910 Fahrenheit to below 817 Fahrenheit. For the action plan or resource needs, for the number 1 is calculate the rate of heat transfer using the heat transfer equation. And number 2 is calculate the time required for the glass to cool down from 910 Fahrenheit to 817 Fahrenheit below. And the number 3 is determine the available working time between 9 a.m. and 12:30 p.m.
Hello, my name is Sufi Haziq Shazani bin Hafizi, and I would like to share with you guys problem solving of question 11. So question 11, we can read the question. So we go to the first question. Approximately how many atoms were in the initial time of the research? So to find this problem solving of question 1, question A, so we have to find the initial number of atoms. So we can use the exponential growth formula for radiative decay. So n is the number of atoms, and O is the initial number. So we can read the formula is given. So Nt is the number of atom time at time, and O is the initial number of atoms, K is the decay constant, and E is the base of the natural logarithm. So we are given from following information: 1 year 490 and 3 year 340. So using the values, we can set up the two equation. What equation is 490 is equally and 340 is equally. So dividing the second equation by the first equation, we get this. So we get this. So we simplifying, we have this. So now we can take the natural logarithm of both sides. So applying the logarithm property, we get this. So using a calculator, we find K is equal to 0.3567. So now we can substitute the value of K 1 into the one of the original equation to find NO. So we can simplifying the equation. So dividing the both side by exponential, negative 0.3567, get this. So calculating this value, we find NO is equal to 704. So therefore approximately 700 atoms were present at the initial time of the research. So we have the answer of question A. Okay, we go to the question B. Question B is find the half-life time of this radioactive element. So the half-life, we know, is take time for half of the atoms to decay. We can find the half-life using the decay constant K we calculated earlier. So the half-life T is related to decay constant by the following equation. So we can do this equation. So using the value of K, we can calculate the half-life. So the half-life is, when we calculate it, we get half-life approximately 1.942 years. We go to the next question. C. How many atoms left after the fifth year? So we can see at this screen. To find the number of atoms left after fifth year, we can use the exponential decay formula. What formula? Is NT is equal to NO times E exponent E negative KT. So we have to start taking the known values we have. 5 years equal to this. So calculating the value we find and 5 years, this equation, we get NO times E exponential negative 1.7835. So therefore the number of atoms left after the fifth year will be approximately NO times exponent E to the power of negative 1.7835.
Assalamualaikum warahmatullahi taala wabarakatuh. Nama saya Muhammad Danish Aizam bin Ismailuddin. Nombor bateri adalah AA221072. Pada bahagian saya akan menjelaskan tentang bahagian problem and solution. Setelah memahami soalan ini, kita dapat menggunakan metode Newton Law of Cooling. Yang mana Newton Law of Cooling ini ia menyatakan rate of change of temperature of an object is directly proportional to the temperature difference between object and its surrounding. Okay? Apabila kita mengamati soalan tersebut, soalan itu memberikan nilai yang boleh kita masukkan ke dalam formula kita. Soalan itu dia ada bagi initial temperature, final temperature, dia ada bagi room temperature, also dia ada bagi masa yang boleh kita tetapkan, dan kita akan masukkan ke dalam nilai ke dalam formula kita. Untuk mencari nilai K, kita boleh menggunakan informasi yang telah diberi, iaitu 0.5 hours semasa gelas itu direkodkan suhunya adalah 910 Fahrenheit. Okey, kita akan masukkan ke dalam formula, dan 910 sama dengan, kita akan tolakkan 1120 Fahrenheit tolak dengan 76 Fahrenheit, and then kita akan darabkan dengan E eksponen kuasa negatif 0.5 K, dan setelah kita susunkan dan kita asingkan, kita akan dapat nilai K sama dengan negatif 2 darabkan dengan lun 910 bahagi dengan 1044. Okey, sekarang mari kita selesaikan masa yang diambil oleh gelas untuk sejuk di bawah suhu 870 Fahrenheit. Okey, kita akan masukkan juga ke dalam nilai yang kita dapat ke dalam formula, dan setelah kita kira, kita akan dapat jawapannya adalah 13.1 minit. Okey, ini bermaksud proses ini dia hampir mengambil masa 13.1 minit untuk gelas itu sejuk di bawah suhu 870 Fahrenheit. Untuk kita menentukan bahawa sebanyak mana glassware yang boleh disiapkan sebelum masa lunch hour pada pukul 12.30 hari, kita perlu mengira number of glass pieces that can be completed in the available time. Okey, daripada masa 9 pagi ke 12 tengah hari, kita kira 3.5 jam. Seperti yang kita ketahui, setiap kelas web itu memerlukan hampir 13.1 minit. Dengan itu, kita boleh mengira nombor kelas yang boleh diselesaikan dengan membahagi masa yang sesuai dengan masa yang diperlukan untuk satu pieces. Okey, number of pieces is sama dengan 3.5 hours. Kita darabkan dengan 60 minit per hour dan kita bahagikan dengan 13.1 minit per pieces. Dan kita akan dapat 16.79 pieces. So, kita akan bundarkan kepada nombor yang terdekat. Oleh itu, bilangan kelas yang dapat diselesaikan sebelum 12 tengah hari adalah 16. Baiklah, terima kasih.
For discussion and conclusion, it is clear from examining first order ordinary differential equation applications that these equations are crucial tools in several scientific and engineering disciplines. They give us a mathematical framework for explaining and comprehending dynamic system, which enable us to model and examine a variety of phenomena. First order ODEs provide important things into the behavior of system over time, including the population of growth and decline, electrical circuit behavior, chemical process, and economic dynamics. They help us better in comprehend the complicated phenomena by allowing us to forecast outcomes, streamline procedures, create control system, and more. First order ODEs are a vital foundation of scientific and engineering study because of their adaptability and potency, and they have considerably aid developments and breakthrough in a variety of fields. Thank you. That's all.